The next part that you have to do is you have to solve for the velocity at the top of the loop, and that's point C. So at point C, you are moving, but both gravity and normal force are acting on you. Now, I told you in class that for this, I want Fn to equal Fg. I want you to feel, this is your apparent weight, I want you to feel like you normally would feel just laying on the floor. Okay? So that kind of makes the formula a little bit easier. So then that means Fn is going to equal mg. You didn't have to figure that one out on this. The only thing you need to determine is the radius of curvature, of how tight that turn is. And I said the radius had to be between 5 and 10 meters. The smaller it is, the better. So if you're closer to like 5, 5.5, 6, 7, something like that, that'll make the math a little bit easier. All right? So, using that, you're in uniform circular motion. The sum of the forces, two things are acting on you. Fn plus Fg has to equal Fc. These are both positive because they're both pointing in. Fn is mg, and Fg is mg. So this will be mv squared over r. All the m's cancel, and then you can use that to solve for velocity. Now, once you solve for the velocity, you can use it just like in the other parts to get the kinetic energy. 1/2 mv squared. Using that velocity that you found here, find the kinetic energy at point C. Now, here's where it gets a little tricky. Point C has two kinds of energy. Because you are up off the ground, you have height, but you're also having velocity. So your total mechanical energy equals the kinetic energy at C plus the potential energy at C. You already got the kinetic energy at C. The total mechanical energy is the same as the potential energy at point A. So since you have that, you can subtract it and solve for PEC. Potential energy at point C. And then once you have that, you can use that to solve for the height at point C.